In today's video, we're going to look at how to construct a Bohr diagram for an element and how to draw energy level diagrams, a related idea. Before we jump in, let's just quickly review some important concepts. The atomic number of an element, pause the video and write the definition down if you don't know it, is the number of protons in the nucleus of the atom. So atomic number is a number of protons in an atom's nucleus. You remember that protons are the positively charged particles within the nucleus. If it's the number of protons, then an atomic number must be a whole number. You're counting how many protons are in the nucleus. When you look at a periodic table of the elements, you notice that the elements are organized in terms of their atomic numbers. The atomic number on this periodic table is the whole number above the symbol of the element. So for lithium, the atomic number is 3. Every atom that has 3 protons in its nucleus would be a lithium atom. The smallest atom on the periodic table is hydrogen, and hydrogen atoms have 1 as their atomic number. So every hydrogen atom will have 1 proton in its nucleus. Helium atoms have 2 protons in their nucleus. When you look down further on the table, uranium, element number 92, its atomic number is 92, so it has 92 protons in its nucleus. So the atoms on the table are arranged by increasing atomic numbers. The number of protons in the nucleus tells you which element you're dealing with. Another important idea is the mass number. The mass number is the number of protons and neutrons combined within the nucleus of the atom. So again, pause and write that definition down if you need to. It's the number of protons together with the number of neutrons in the nucleus of the atom. Protons and neutrons are approximately the same size. They each have a mass of 1 atomic mass unit. Compared to electrons, the mass of a proton or neutron is incredibly large. Electrons are very small. They're almost massless. So within an atom made of protons, neutrons, and electrons, the mass of the atom is essentially due to the protons and neutrons. So looking at the nucleus, the number of protons and neutrons together is the mass number. Again, it has to be a whole number because you're counting protons and neutrons. When you look at a periodic table, the only whole number in each box is the atomic number. So mass numbers are not found on the periodic table. That's an important point you want to remember. Atomic numbers are on the periodic table. Mass numbers are not. And the reason for that is that each element can have different isotopes. Each isotope of an element has a different mass number. So for example, most hydrogen atoms have only 1 proton in their nucleus, so the mass number of most hydrogen atoms is just a 1. But a few hydrogen atoms in nature have a proton and a neutron in their nucleus. So a few hydrogen atoms will have a mass number of 2 because they have 1 proton and 1 neutron in their nucleus. An even smaller number of hydrogen atoms in nature have a mass number of 3. They'll have 1 proton, that's what makes them hydrogen, and then they have 2 neutrons. So there's 3 different isotopes of hydrogen. Hydrogen 1, where the mass number is 1, hydrogen 2, where the mass number is 2, and hydrogen 3, where the mass number is 3. So with 3 different mass numbers for hydrogen, they're not shown in the periodic table. There's not enough room to show all those different mass numbers for every element. So we're going to draw a Bohr diagram. Okay? Niels Bohr, that's the name of the physicist, chemist who gave us this idea. Niels Bohr said that the electrons in an atom are not just outside the nucleus, but rather they're found in energy levels orbiting the nucleus. So here we have an isotope of nitrogen, nitrogen 13, and we're going to draw the Bohr model, the Bohr diagram for this isotope. The 13, after the name nitrogen, is the mass number. So again, that's the number of protons and neutrons in the nucleus. You could also have written the symbol for this isotope as the capital letter N, the symbol for nitrogen. Then you'd put a 13 on the top left. That 13 is the mass number. And on the periodic table, if you look up nitrogen, you'll see that nitrogen's atomic number is 7. So the atomic number of nitrogen is 7. So down here, this symbol for nitrogen is sometimes written a 13 on top and then a 7 down below. 13 is the mass number on top, 7 is the atomic number on the bottom. The 7 is the number of protons, the atomic number. The 13 is the number of protons and neutrons combined, which is the mass number. So if you subtract those things, 13 take away 7, you'll get 6, which represents the number of neutrons. So in this isotope of nitrogen, we can tell that there are 7 protons, because its atomic number is 7 on the periodic table. There's going to be 6 neutrons, because 13, the mass number, minus 7, the atomic number, is 6. There's 13 protons and neutrons, but there were 7 protons, so that means there must be 6 neutrons. 7 plus 6 gives you 13, the mass number. Now remember, protons are positive, neutrons are neutral, they have no charge. The electrons in the atom are negative. If the atom is neutral, the atom itself has no charge, then there must be an equal number of positives, the protons, as there are negatives, the electrons. So if the atom is neutral and we have 7 protons, there would have to be 7 electrons also. So in every neutral atom, the number of protons will equal the number of electrons, because the positives will equal the negatives to make it neutral. So now we have enough information to construct our Bohr diagram. In the nucleus of the atom, we'll write 7 protons and 6 neutrons. That's our nucleus. We know there are 7 electrons orbiting the nucleus. In the Bohr model of the atom, the electrons orbit in energy levels, or orbits, and I'll show those with a little dotted line. There are an infinite number of orbits in an atom, but according to the Bohr model, in the lowest energy level, when the first energy level, n is equal to 1, you can hold a maximum of 2 electrons. So this lowest energy level holds a maximum of 2 electrons. The second energy level, the second orbit in the atom, can hold a maximum of 8 electrons. The third energy level in the atom can actually hold up to 18 electrons in the Bohr model. And there are an infinite number of orbits, and the number of electrons in each orbit, in each energy level, just increases as you go up. There is a little formula, though, if you're interested. When you have an nth energy level, the number of electrons that can fill it is 2 times n squared. So for example, when n is 3, 2 times 3 squared would be 2 times 9, and that's where we got the 18 electrons from to fill it. In this course, we won't go past the third energy level, so we'll never need more than the 18 electrons there. In fact, in all of the examples that we'll see, we'll never actually have more than 8 electrons in the third level. We won't go past that. So let's go back to our diagram of nitrogen. Its atomic number was 7, so there are 7 electrons as well as protons. 2 of those electrons can go in the first energy level. When I draw them, I just represent them as dots, and I put them opposite each other like that. So there's 2 of our electrons in the first level. We have 7 electrons total, so that means we have to put another 5 electrons, and they're going to go in the second energy level. The second level can hold up to 8 electrons, so we can easily put 5 in here. Put the first electron wherever you like, put the second electron 90 degrees away, put the third electron again 90 degrees away, and the fourth one again 90 degrees away. And now the fifth electron, pair it up with the first one. So there would be the Bohr diagram for nitrogen 13. 7 protons, because the atomic number on the periodic table is 7. 6 neutrons, because 7 plus 6 gives me the mass number, which was 13. And because there's 7 positive protons, there had to be 7 negative electrons, 2 of them in the first energy level to fill it, and then 5 of them in the second energy level. The electrons that are in the outer energy level, in this case the second level, those are called valence electrons. These are the highest energy electrons in the atom. So for nitrogen, there are going to be 5 valence electrons that are in the second energy level. Those are the valence electrons for nitrogen. Try it again with fluorine 19. Look on your periodic table. The atomic number of fluorine is 9. So that means there are 9 protons in this nucleus. 19 is the mass number. So this isotope of fluorine could have been represented as the symbol F, 19 over 9. 19 on the top is the mass number, and 9 on the bottom is the atomic number. If there's 19 protons and neutrons total, that's what the mass number means, and we know there are 9 protons, then how many neutrons were there? Well, the answer is 10. 19 take away 9, there's going to be 10 neutrons. Notice 10 plus 9 gives me the mass number, 19. So there's my nucleus. Now, if there are 9 positive protons, there have to be 9 negative electrons as well. Protons and electrons will be equal because they have opposite charges and the atom is neutral. So of those 9 electrons, we can put 2 of them in the first energy level. So just put them like this on the opposite sides of the nucleus. That would be okay. Now we have another 7 electrons to go in the next level. So in the second energy level, we can put up to 8 electrons, so the 7 electrons that we have left can easily fit here. Put the first electron wherever you like, but then go at 90-degree intervals. 1, 2, 3, 4. We have 3 more electrons. Start to pair them up. So there's 5, there's 6, there's 7. So there are the 7 electrons in the second energy level. So this isotope of fluorine has 9 protons, 10 neutrons in its nucleus, 9 electrons around the nucleus, 2 in the first energy level, and 7 in the outer energy level. So that means it has 7 valence electrons. Those are the electrons in the highest energy level. So Bohr diagrams, pretty straightforward. There's a related idea called an energy level diagram. This is similar to a Bohr diagram, but easier to draw. For example, let's draw the energy level diagram for carbon. Notice we don't specify the mass number, so I'm not really interested in any particular isotope of carbon. we're just focusing in an energy level diagram on the electrons, the electrons in energy levels. To draw the diagram for carbon, you put the symbol for carbon, so a capital C. You look on the periodic table and find carbon. Carbon's atomic number on the periodic table is number 6. So it has 6 protons in its nucleus. Coming back to our diagram, we'll write 6 protons above the symbol. So that's from its atomic number. Then we're going to write the fact that it has 6 electrons. The protons and electrons are equal, and we're going to show them in energy levels. So I'll draw a little dash like this. This is the first energy level. It can hold 2 electrons. We have 6 electrons, so that means if we put 2 of them in this first level, we're going to need to put 4 of them in a second energy level. So those are the electrons in level 1 and level 2 in the carbon atom. The electrons in the highest level are the valence electrons, so there are 4 valence electrons in carbon atoms. There is the energy level diagram for carbon. Let's do the same thing this time for phosphorus. Write the energy level diagram for phosphorus. So we glance at phosphorus on our periodic table. Phosphorus has an atomic number of 15. So it has 15 protons in the nucleus. Coming back down here to write the energy level diagram, we'll put the symbol for phosphorus, the letter P. We'll say that there are 15 protons in its nucleus. That means it has to have 15 electrons also. Protons are positive, the electrons are negative, and the atom is neutral, so they're equal. The 15 electrons, well, where are they? 2 of them are in the first energy level, and now it's full. We have another 13 electrons to go. 8 of them can fit in the second energy level, and now it's full. So we've put 10 electrons so far. We have 15 total. So that means the third energy level will have 5 electrons. 2 plus 8 is 10, plus 5, there's our 15 electrons total. The outermost energy level, in this case, is the third energy level. So that means phosphorus has 5 valence electrons. There's the energy level diagram for phosphorus with the number of valence electrons indicated as well. So hopefully you now understand how to draw an energy level diagram and how to draw Bohr diagrams with their energy levels. You can hopefully study for this for a test with this, review for a test or exam. Don't forget to keep them separate in your brain. The Bohr diagram shows the nucleus and the orbits. The energy level diagram does not. So on a test, make sure you draw the right thing for the question you're trying to answer.